So what we have here today is a total dissolved solids probe. So what it does is it measures the conductivity between these 2 points over here. It's a resistance measurement. So normally this would be temperature compensated. So on a commercial instrument like this, you've got a temperature sensing bulb in the bottom beside your 2 probes. So this from Dev Robot is a total dissolved solids meter. So that's converting this resistance measurement into an analog out. And over here I've got it connected to an Arduino Uno. This is a revision 4, which means that we got 14-bit resolution on the analog input. Also, it is writing the analog value measured out again over a PWM. So when I dip the probe in the water, we can see it on the meter over here. So I've got 2 Petri dishes over here on my resplendent new silicon pad, which I acquired. So here we have 2 samples of water. We have tap water, and we have tap water with sodium chloride added to it. So when I dip the probe in there, we get a reading of 1.1 volt. So that would be, this thing is scaled for 0 to 1000 parts per million. So we're looking at about 100 ppm. When I take this and I dip it into the water with the sodium chloride, it goes for a scale. And then back into our tap water, like so. So there you can see the analog value out, and also on the computer, or confuser as I like to call it, we can see the value being transmitted over serial comms. So let's power up the commercial probe. That's reading 0 at the moment. So when I dip it in my water, like so, I'm reading about 300 microsiemens. Not sure how well that's going to show up on the camera. Like that. Now if you set that aside, now in the salt water, we got 54. So there we can see quite a different reading. So that's about 100 as we measured this probe over here. Like so, there's now a little bit of salt present in that tap water. So one can actually see that reading going up. There's a lot of salt was added to this dish over here. So you can see I just contaminating this water with having had the probe in there has made a difference to our measurement over here. Quite a bit. So that's that. So I'm going to dry off that probe. So we don't have any salt crystals growing on it. Cover up our specimens again so we don't make a mess if we bump something. And let's have a quick look at the code on the confuser in the Arduino IDE. So I'll see you over there at the computer. So bring our microphone closer. So as you can see, here's our code. Analog 0 is being used to read the value in from the sensor board, and analog output pin 9 is our PWM out that I've got the multimeter attached to. We've got sensor value, which is where our analog read value gets stored, and we've got output value, which is where we store the value to do the analog write. We get serial comms going at 9600 baud, and we set our analog input for 14 bits of resolution like that. We then do an analog read. So we're reading analog input 0, storing the value in sensor value. We are scaling it, so output value, the 14-bit value 16383 is becoming a value of 0 to 1000. We then write the analog value, output value, to the analog output pin, which is pin 9 over there. We then print this data out over serial. Down here we send the sensor value, the output value, with some text. So we send the text first, then the sensor value, and then we send text again, and then the output value. So if I take my probe and I dip it in the water, then you can see the value go up. And if I take my probe, open the petri dish again, dip it in the salt water, there's our reading, like so. And then we have our probe in the fresh water, tap water, like so. And that is total dissolved solids. Now this is not a temperature compensated reading, so this is based on you taking a measurement at 25 degrees C. So the conductivity of the water rises as the temperature of the water rises, which is why the commercial instrument has got a temperature sensing bulb, and it compensates the reading based on the temperature measurement of the liquid being measured. And that's it. I'm enjoying the new Uno revision 4. Today I unpacked it for the first time, so this is very nice. Look forward to doing more work with it. It's got lots of extra features. It's going to be very nice. And I think we're going to wrap this video up at this point, and not much more to say about it. I thank you for joining me here today. We learned something new, we played with a new toy, and we had a good time. Thanks, ladies and gentlemen. Have an awesome day further. See you back next time for more. Cheers.